In just under 48 hours, the AI research world was rocked by not one, but three significant breakthroughs. Deepseek unveiled a massive 671 billion parameter model that verifies mathematical theorems. Xiaomi released a highly efficient 7 billion parameter model that punches well above its weight class. And Microsoft presented a versatile 14 billion parameter reasoning model that rivals top-tier systems. This isn't just a numbers game anymore, it's about precision, creativity, and real-world usability. Let's watch these game-changing innovations. Deepseek's Prover V2, automating mathematical rigor. Deepseek has made a name for itself by pushing boundaries, and its latest release, Prover V2, continues that legacy. Hosted on Hugging Face, this model isn't just large, it's colossal, clocking in at 671 billion parameters. Despite its intimidating size, the model is openly licensed under the MIT license, a rare move that emphasizes transparency and accessibility. What makes Prover V2 extraordinary is its capability to verify formal math proofs, not just by providing symbolic answers, but by translating Olympiad-level problems into formal Lean-4 code and generating machine-verifiable proofs. This is academic-grade work executed in mere seconds, which were both built on a 7 billion parameter DeepSeek math base, trained primarily on synthetic data. Prover V1 was optimized for training efficiency and execution speed, leading to improved test accuracy. V2, however, is in another category altogether. It appears to be built on the robust foundation of R1, which made headlines last year by matching OpenAI's GPT 4.0 model in performance tests. Prover V2 goes a step further by compressing vast amounts of mathematical knowledge into a format that allows it to write and verify rigorous proofs effortlessly. But what does this mean for practical use? Quite a lot. From automated grading and educational tools to cryptographic verification and advanced mathematical research, the applications are broad and impactful. Formal methods are critical in fields like cryptography, where logic verification isn't a luxury, it's a necessity. The model's open weight release has generated a mixed response. While some celebrate it as a win for open science and accessibility, others worry about the security implications of releasing such powerful tools to anyone with access to sufficient hardware. The debate echoes the reaction to DeepSeek's R1 model, highlighting the tension between innovation and responsibility. Under the hood, the use of FP8 quantization is a game changer. Most standard models use FP16, doubling memory demands. By cutting this in half, Prover V2 improves memory bandwidth efficiency and inference speed, making the model more accessible to those with high-end, but not supercomputer-level hardware. Additionally, techniques like model distillation, where a smaller student model learns from the larger teacher, suggest that lighter variants like Prover Lite could eventually run on workstations or even laptops. The AI community is already experimenting with various quantization techniques, including 4-bit and even 3-bit models, to strike a balance between precision and performance. If the roadmap set by the R1 release is anything to go by, we can expect optimized, smaller versions of this model to be used in academic labs, corporate research setups, and perhaps even personal workstations in the near future. Xiaomi's MiMo 7B. Lean, mean, and built for code from Beijing, we move to Shenzhen, where Xiaomi, a brand better known for smartphones, is making waves in AI with its MiMo 7B model. Unlike the giants competing in the 30+ billion parameter space, MiMo 7B comes in at a modest 7 billion. But don't let its size fool you. This model has been finely tuned for reasoning, particularly in coding and math, and it outperforms models more than 4 times its size. Xiaomi's secret sauce lies in its massive pre-training dataset of 25 trillion tokens, processed through a 3-stage data mixing pipeline. By the final stage, math and coding tasks made up 70% of the training data. This focus gives the model razor-sharp capabilities in its target domains. The model also supports a whopping 32,768 token context length. This means it can keep entire code bases or long mathematical proofs in memory without losing context, a crucial feature for debugging complex systems or solving multi-step problems. This extended memory makes it incredibly useful for developers who deal with large scripts or deeply nested logic. Another standout feature is its use of multi-token prediction. Traditional models predict 1 token at a time, which can be limiting. By predicting several tokens simultaneously, MiMo 7B offers faster inference and more cohesive reasoning. This is especially important in coding and mathematical tasks, where logical flow and speed are paramount. After training the base model, Xiaomi forked it into 2 reinforcement learning variants, RL0 and RL. RL0 starts from the base model's raw weights, while RL builds upon a supervised fine-tuned version. Both were trained on a curated set of 130 30,000 verifiable math and coding problems. Xiaomi introduced a difficulty-driven reward system to incentivize solving harder problems, and to avoid overfitting, they implemented a clever data resampling strategy that reduces the frequency of easy tasks during training. The performance metrics speak volumes. On the AMI 2025 benchmark, MiMo 7BA RL scores 55.4, beating OpenAI's 01 Mini by 4.7 points. On Live Code Bench Vive 5, it hits 57.8%, significantly outperforming Alibaba's 32B parameter QWQ model, which trails at 41.9%, while Alibaba's newer Qwen 330 BA3B leads with 62.6%. The fact that Xiaomi's 7B model is even in the same league is astonishing. Moreover, this isn't just a cloud-based tool. With enough VRAM, it runs locally, empowering developers with privacy, control, and the ability to build without relying on APIs or data centers. Xiaomi admits the model has quirks. Heavy math use can slightly reduce coding accuracy, and it occasionally lapses into Chinese mid-response during English tasks. But these are minor hiccups. All three variants of the model are available on GitHub under a permissive license. Xiaomi also teased upcoming control tools that will let users dynamically toggle the model's personality and domain focus. Whether you're deep into math, buried in code, or switching between both, MiMo 7B is designed to adapt. This is not just a small model with big dreams, it's a tactical entry into an AI future where intelligence isn't measured by size but by capability. Microsoft's FI4 family, scalable reasoning with precision. Last but not the least, Microsoft has entered the fray with the FI4 family of reasoning models. Anchored at 14 billion parameters, FI4 sits comfortably between Xiaomi's 7B and Deepseek's 671B behemoth. But don't let the middle ground size fool you. This model family is sharply tuned for math, science, and software reasoning. The FI4 family consists of 3 versions. Microsoft's goal is clear: deployable, efficient reasoning AIs tailored for education, software QA, and engineering simulations. Instead of relying on raw data volume, Microsoft curated 1.4 million boundary prompts, edge cases designed to push the model's limits. These prompts were paired with reference answers from OpenAI's GPT 3.5 in high reasoning mode. Each training sample was formatted with explicit tags separating chain of thought reasoning from the final answer, teaching the model to think before speaking. Microsoft also matched Xiaomi's 32K context window by adjusting rope frequencies, ensuring that the model can handle large-scale input without truncation. The FI4 Plus variant was then polished using group relative policy optimization on 6,400 complex math puzzles. The reward function penalized repetition and verbosity, encouraging clear and concise answers. The results are impressive. It even generalizes to planning puzzles like the traveling salesman problem and 3 SAT, despite not being explicitly trained on them. This suggests that the model has developed abstract reasoning abilities beyond simple pattern recognition. Deployment is also a key focus. Quantized to 4-bit, the FI4 models can run on single high-end consumer GPUs, making them ideal for classrooms, educational tools, or independent developers. Microsoft's transparency stands out. They've published full training logs and evaluation traces on Hugging Face, inviting audits and derivative work. The company also hinted at future variants aimed at STEM education, including modules for physics, chemistry, and advanced calculus. The implications are profound. When models become so adept at math, logic, and code that they begin constructing systems we can't fully interpret, it raises essential questions. At what point do we transition from creators to observers? And are we ready for that shift? From Deepseek's record-breaking Prover V2 to Xiaomi's lean and efficient MiMo 7B and Microsoft's versatile FI4 family, the past 2 days have redefined what's possible in AI-powered reasoning. Each model brings something unique: deep mathematical rigor, coding precision, or balanced general-purpose logic. We're witnessing a moment where open science, clever training strategies, and hardware-efficient designs are converging to create models that are not just larger, but smarter, faster, and more accessible. If this kind of deep dive into cutting-edge AI excites you, don't forget to visit judyfmarketing.com for more insights, updates, and resources on the latest in AI and tech innovation. Thanks for watching, and stay tuned for more breakthroughs ahead.